Hello dear students, welcome to your class. So today we are going to start chapter number 3rd, which basically deals with laws of motion. These are the very specific, or you can say very basic laws of physics, okay, which we are going to discuss right now. So it is one of the basic laws of physics that we are going to deal in this chapter. The Newton's three laws of motion are considered as the base of the classical physics. Okay, there are the two branches of physics, classical and modern. So we are not going to indulge into this. So only you keep in mind that these are the laws of motion which lays the foundation for the classical physics and the classical mechanics basically. And as name suggests, Newton's law of motion. Okay, it's not written over here, but these three laws are basically propounded by Newton. Except first law. First law is basically given by Galileo, a much earlier from Newton. So Newton's law of motion we are going to deal in this chapter. So before understanding this, okay, we have to know about the basic concepts of force. Before understanding the Newton's law of motion, okay, we need to understand about the force, because force is that kind of physical quantity which exists since time immemorial. People know that when you push or pull anything, it means they are exerting force, but they don't know how exactly force should be defined. Okay, so that it gives you a proper imagination of how force acts on a body. So to understand this kind of thing, Newton propounded and researched very well and give these three laws. So before understanding this, we have to know about the force first. So what force is basically? In common phenomena, we can say force is nothing but push or pull. In anything, if you push with some agent, or in physics term, the property, or you can say the body which applies a force, it's considered as an agent. Okay, if anybody would say that if an agent applies a force, it means the body who are applying the force, the body who is applying the force in general cases, right. So first of all, what force is? So push or pull we generally consider as a force. Now, what kind of effect a force can produce when it applies on a body? So there are the three basic effects that we have. First one is it can change the state of rest or state of motion of the body. It can change the state of rest or motion of a body. It means if a body is in moving condition, so to stop this body, you need to apply a force. Okay, so this kind of force is called non-contact force. We'll discuss later on. First, you see the function. The very first function of the force is to change the state of a body. Means if a body is in the state of rest, okay, so to move this body or to make the state of this body into the motion, then we need to apply a force on this. Okay, and in similar way, if a body is in motion, so to stop this body, it means to convert the state of motion of this body into the state of rest, we need to apply another force. Like for example, to start a bike, you need a self start that we have on bike, and to stop any kind of vehicle or any kind of bicycle, you need to apply a brake. So brake is also a type of force, and the accelerator or the engine that is being applied, or the engine, or in the case of bicycle, you are applying a force on the pedal. So this pedal or this engine is basically the agent which applies force on that body. That body means on that bicycle or motor vehicle, to change the state of this vehicle into from rest to the motion. So to convert the state of any body, we require a force. Conversion of a state means when the body is in rest, when the body is at rest, to convert this body into the state of motion, and when the body is in the state of motion, to convert this state into the state of rest. So this is called first effect of force. Now the second one, it can change the direction of motion. Similar way, you also know Very good example of this is in football playground, okay, or in cricket also. So if bowler bowls you, okay, so what we did, just doing a flick like this. So what you're doing, you're applying a force with the help of the bat, and when the ball is coming from here and you're batting like this, and when ball is coming and you just flick this ball, okay, so when you flick this ball, then what happened, this ball will just rotate to the ground, to the boundary line or the boundary rope. How these things are happening? The force, the body is in motion, the body is the ball. So the ball is in motion, and by applying a force with the help of bat, you just change the direction of motion of that ball. At first, the ball is coming towards the stumps, okay, and when you are applying a force with the help of the bat, so the ball is traveling towards the boundary line, okay, so and sometime towards the hand of the fielder also. It's not necessary. It's based on your talent, how good batsman you are. Okay, leave it. So when you are applying a force with the help of bat, so the ball will travel towards the direction of boundary line. So what we are doing here, by the application of force, we are just changing the direction of the body or the direction of motion of the body, that is ball. So the second case is it can change the direction of motion. We can change the direction of motion with the application of force. Next thing, it can change the shape or size of the object. Similar way, shape and size. Take a sponge and just apply a force from both the direction. You might have seen shape may change, right? If you are having a dough of flour, okay, so when you just bind the dough, what happens? It compresses. Like you are packing a suitcase, no? You are packing a suitcase, so when the clothes is just overflowing from your suitcase, from your trolley bag, then what you will do, you are just applying a force to fit these luggage into that shape. So by the application of force, we can change the shape or size of the object, and this kind of force can also be regarded as deforming force. Deforming force means you are changing the shape or size, or the shape and size collectively called configuration. Remember this thing, configuration. Configuration. The shape and size are collectively called configuration. Okay. So now we had completed the effect of force. Now next thing you see, types of forces. So there are basically two types of forces in accordance with their generation. Okay. Or you can say according to their generation, the force can be divided into two categories. One is called contact force, and another one is so obvious, non-contact force. Right? First one is contact, another one is non-contact force. So what is contact force? Contact force means, I've already told, there are the two things. Okay. One is agent. Agent means which is applying a force. Like I've given the example just now that bowler is bowling. Okay. So ball is the body, and with the help of bat you are applying a force. With the help of the bat you are applying a force. So your bat is acts as an agent, okay, which applies the force on the object, that is the ball. Okay. So when there is a connection or when there is a physical contact between the agent which is supposed to apply the force and the body on which the force is being applied, so these are called contact force, when there is a physical connection between them. Like I've given this example, okay, with the help of bat and ball, and there are the different types of forces in which the contact must necessary. So these are the different forces in which contact is necessary. So there are the 5 types of forces which are given, that is friction force, normal reaction force, force of tension, force exerted by the spring, and force exerted due to collision. So one by one we are going to study all those forces. Force of friction. What force of friction is? Okay, you might have seen when you roll the ball, okay, when you roll the ball, so after some time the ball stops. Why these things are happening? Because if you see closely, there is a floor. So floor is made up of that kind of physical arrangement, and if a body is rolling over this, so body is also having this kind of jerks on its surface. So these two jerks are combined together. So this force will oppose the motion. Supposedly, if you are applying a force here with your hand to roll this body or to slide this body over a surface, then there is another force comes into play in opposite direction which opposes the motion. So the force which opposes the motion is called frictional force. So if anybody would ask what is frictional force, so frictional force is everywhere. If frictional force is absent, then we are not able to walk on the surface. Okay, due to this frictional force, the frictional force binds us with the surface, right? So in that case, what happened? A friction force is necessary for any kind of movement. So you can minimize the friction, right? You can minimize the friction by adding some lubricants. Okay, so if the surface are more rough, the more friction they may produce, right? So to reduce this friction, we add lubricants like oil and all those things to smoothen the movement. Okay, so that's why bearing of fan, bearing of wheel of car or bicycle is being oiled regularly. Why? To reduce the friction. Because during the time, as the time passes, so what happened? The surface goes wear and tear because of the regular use. So the jerks, or you can say the irregularities on the surface of those things being more. So when irregularities are more, then they produce more friction. When they produce more friction, then it is really difficult to move further. Okay, so in some cases, friction is really good for the people to which helps us to walk on the surface. But in some cases, friction are bad also for the machinery. Okay, because they produce heat also, and it will very difficult to work on that kind of machine. So this is frictional force. So what basically frictional force is? So frictional force are those force which opposes the motion. Okay, it always acts opposite to the direction of motion. Supposedly the body is supposed to move in this direction, so frictional force always applied in this direction. So these are the contact force. You see, there is a close contact between this body and this surface. Okay, in this case, just keep in mind one thing. In this case, which one is body and which one is agent? So the brick or the solid substance which I have shown, it is the body, and the agent which is applied, the frictional force, is the surface. So surface always applies the force on the body, so which acts as an agent. I hope frictional force is clear to you. Now the next kind of force, always remember one thing, this is really vital for you, that forces always acts in pairs. Okay, force cannot be act singularly. Normal reaction. So this is normal reaction force. What normal reaction force basically is, suppose this is the surface, and if I place a body over the surface. So we all know, for the basic property of the body or any matter, it must possess mass. And when anything possesses mass, so acceleration due to gravity comes into play, then it must possess some weight. So weight is equal to m into g, mass into acceleration due to gravity. So if the basic property of any substance is mass, and if any body is having mass, it must have some weight, because when mass is multiplied by gravity, it will gives you weight. So the direction of weight is always downward direction. So to overcome with this force, there is another force comes into play in upward direction, which is called normal reaction, denoted with R. So normal reaction is the force which comes into play due to the opposing force of weight of a body. So this is the weight of the body, which is downward direction. So this is the normal reaction of force, which is in opposite to the direction of weight of that. So direction of weight of a body always acts in downward direction, and the direction of normal reaction is always in upward direction. I hope these things are clear to you, right? Okay, so this is normal reaction force. Normal reaction force due to weight of a body. Third one, force of tension. So tension is a special case of, tension is nothing but it is the special case of normal reaction. How you see? This is a rigid wall, this is a string, and we have a body which is tied with the string. Okay, so this is the body, this is the string. So we all know anything which have mass must possess weight. Weight is in downward direction. So when weight comes into play, it is so obvious that normal reaction comes into play. So you see, when normal reaction is opposite to the direction of weight, so this normal reaction somehow coincides with this string. So this force which comes with the reaction of the weight when it is hung with the string, it is called tension. Okay, so tension always acts in the string towards the rigid wall. Tension always acts towards the wall, okay, towards the fixed position. Always remember, when you act a body like this, when you tie a body like this, okay, so it always acts here towards the rigid wall. So direction of tension, always remember, direction of tension is always upward. It means towards the fixed end. Okay, so this is called tension force. Now next thing, force exerted by spring. Force exerted by spring. So we all know, supposedly this one is a spring, and if you just move a spring, the spring contracts, and when you release, there is some force is being exerted. So somehow is given the formula K into X. K is called spring constant. It depends on the material of the spring, which kind of material you are using. So this is also a formula, so we are not going to talk about this much. You always remember the force exerted when you have a spring, then there is a ring of the spring collapses, and when you release, so they exert a force on a body which is just placed over here. Okay, like for example, I will give you one more example. Supposedly, first one end of the string is fixed and another end is free. If you have a book or anything, and with the help of this book, you just shrink this spring over here, like see, like this. And when you release your hand, you might have seen this spring will throw this book very far away. This kind of force is exerted by spring, so it is called spring force. Remember the formula minus kx. X is called displacement and k is spring constant, which depends on the material of the spring. So we don't need much in this chapter. It is not also given in your book, so leave it. Now next thing is exerted by the two body due to collision. Collision means what? This is a body having mass m1, this is a body having mass m2. When these two are moving in a direction, this one is having velocity v1, this one is having velocity v2. But this body is moving with velocity v1 and this body is moving with velocity v2. So after traveling some distance, when they will collide, okay, when these two will collide, then after collision it will change its direction of motion and its velocity also changes. Okay, we don't know what velocity is, but its velocity also changes. But when they both collide with each other, their direction of motion also changes and their velocity also changes. So these are called collision. So in some cases you can write u1, this one is u2. So after collision its velocity becomes v1 and v2. So in certain cases we are writing initial velocity or final velocity always constant. Okay, initial momentum or final momentum constant. So we are writing m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is the formula for the collision. It is called, there are the two types of collision, elastic collision, inelastic collision, which are not included in your syllabus. Only remember these things. This is called momentum or conserved. Okay, leave it. So always remember the collision forces when two bodies comes in contact, when they are moving with some velocity. So after they come closer, then they will move apart with some different velocity. So these are called collision, right? So that's all for the contact force. Now the next thing we are going to do is non-contact force. Okay, non-contact force. See, as we know, in the case of non-contact force, okay, there is a physical contact between the agent and the body, but in the case of non-contact force, there is no direct or physical contact between the body and the agent. Okay, so example will give you a proper idea. There are the three forces we are going to discuss under this heading. First one is gravitational force. There's another section of this one in this chapter also. That is E section. Gravitational force. Second one is electrostatic force. Third one called magnetic force. Okay, gravitational force, electrostatic force, and magnetic force. So one by one we are going to discuss. First one is gravitational force. We all know gravitational force applied by Earth. No, this is the very wrong concept. Gravitational force is not only applied by the Earth, but every body which is inside the universe. Okay, but every kind of body which resides in the universe will apply the gravitational force, okay, on each other. I and this duster and this chalk, they both are applying a gravitational force on each other according to Newton. This is a very new, always keep this thing. Gravitational force is not only the force which is applied by the earth, it is called earth gravity. Separate name are given. But according to Newton, everybody if you are having, supposedly there are the two bodies, one is having mass m1, another one is having mass m2, and they are separated apart, the distance supposedly r. Okay, so any kind of body if they are having, so this kind of force comes into play, but due to the different factors like air resistance and due to their smaller size of mass, this force we cannot able to observe. Very minimal amount of force is being there. Okay, so m1 and m2, what Newton says, so there is a formula for the gravitational force. It is directly proportional to the product of masses m1 m2 and inversely proportional to the square of the distance between them, and there is a one constant will come, that is g. Okay, g is called gravitational constant, so it is f g m1 m2 upon r square. So this value of force is really small because value of mass is really small, okay, as compared to the mass of earth or any gravitational force. Achha, why earth gravitational force is only observable? So this is due to the huge mass of the earth as compared to that body. So as compared to this duster, the earth mass is really huge. So that's why we can able to observe the gravitational force of earth on any kind of body which is falling towards the earth. Right? So F is equal to G m1 m2 upon r square. So it is called gravitational force. What they are called? Gravitational force. And always remember, gravitational force is always attractive in nature. Attractive in nature. And it is very weak force. Weakest, but weakest force, not only weak, it is the weakest force in nature. Okay, there are some forces which is itself present in the nature, and all these forces, non-contact types of forces present in nature. So gravitational force is those kind of force, okay, which is the weakest, okay, in nature. So in the second case, if G1 G2 will complete it, so which one is the strongest force? Nuclear force is basically strongest force. Okay, people are getting mastery over the nuclear force, so they are able to produce atom bomb, hydrogen bomb. So you might have seen there is a hydrogen bomb is having so much devastative feature in it. Why? Because when you can able to break this strong force, no, so they generate a huge amount of energy which is devastating in nature if you are not able to control it. In some of the cases, this nuclear forces can be used for the production of electricity and for the power generation also, but the gist of this concept is that gravitational force is the weakest force and the nuclear force is the strongest force. So that's why when as long as we get the mastery over these nuclear forces, we can able to produce the most devastating weapons like hydrogen bomb, atom bomb. This all are due to the fact, or due to this fact that nuclear force are the strongest force. When these force broken down, then a tremendous amount of energy can be released. And if you're not able to control those tremendous amount of energy, then it may cause a most devastating features. Okay, and they in return they will give you many disease, and in some different types of devastating features they have. You might have heard about the Hiroshima and Nagasaki. This is due to this nuclear force. Why? Because it's strongest in nature. Okay. Now the next force, this is called gravitational force. You might have seen these two body does not have any physical contact. Now the next one, the second type of force is called electrostatic force. Right? Electrostatic force. In the case of electrostatic force, there are the two charges. They are called Q1 and Q2, and they are r distance apart. So this force F is equal to Q1 Q2 upon r square into K. This is as similar as the gravitational force. Why? Because these kind of forces are called central forces. Central force are those force which depends on the distance between the two bodies. Okay, so any kind of forces which depends on the distance between the two things or the two bodies, they comes under the category of central force. So these are the electrostatic force that we have. So F is equal to K into Q1 Q2 upon r square. So these comes under the category of electrostatic force. We know there are the two types of charges, positive charge and negative charge, and between these charges there are the force comes into play, which force are both attractive as well as repulsive in nature. Attractive as well as repulsive. Okay, these forces are attractive as well as repulsive in nature, on the contrary to the gravitational force, which is only attractive in nature. Now magnetic force, we all know there are the two magnets, south pole, north pole. If you are having, then south pole, north pole attract, and north pole repel. In similar case, positive charge repel, positive negative charge attracts. So these kind of things are happening over here. So electrostatic force and magnetic force are the kinds of non-contact force. I hope these things are clear to you, right? Now A part has been finished over here. In the same lecture, if you want to pause the video, you may pause the video, and in the second session you will watch the forthcoming thing. But I'm going to start here the Newton's first law of motion. It's really easy and shorter topic as compared to the Newton's second law. So first law of motion is quite easy and quite short topic. So I'm going to start in this lecture itself. So it is called Newton's first law of motion. Newton's first law of motion. Okay. So there is an interesting thing. Before Galileo, okay, Galileo is a scientist. Galileo Galilei, you all know about him. So before Galileo, what is believed that to continue any motion, you required a continuous application of force. Why? Because people are continuously in contact of those kind of phenomena in which they have to apply a force on a regular interval. Like for example, on that day bicycle was not there, but if you consider bicycle as an example, so suppose if you are riding a bicycle, so continuously you have to apply a force. Okay, like it means you have to continuously apply a pedal on the body. Okay, paddle on the body, you continuously paddling the bicycle. So it means you are continuously applying the force on a body to make the body in continuous motion. So before Galileo, this was the concept. Okay, means for making a body in a continuous motion, you have to apply a continuous force, which is, and this kind of, this belief, or you can say this theory, was broken by the Galileo Galilei himself by applying experimental phenomena. What they did, he just have these two types of slopes, okay, which he made frictionless, and he rolled the two bodies. First body he rolled, this is a frictionless surface. So what he observed, that the body will go there and it will go in similar height in first way, in the second and in third, when the friction reduced and it will comes into the airtight chamber. So this motion continues. So what he conclude, that everybody try to remember this statement, because law must be written as their propounder propounds this. Okay, as their you can say the person who formulated this law, who has written in such a word, you have to copy this, because law cannot be altered by altering the sentences or words. So remember and learn these words as it was given on that book. Okay, Principia, the name of the book, which is written by Newton. So see, where we are, so I am talking about the statement of the law. So what first law of motion states? So it states that everybody, listen this line carefully, anybody wants to continue its state of rest or state of motion, everybody wants to continue its state of rest or state of motion. Everybody continues a state of rest. Okay, it means to make a body in continuous motion, you don't require a continuous force. What force you will require to make this body stop, or to make this body stop at a particular point? So you need to apply a force only on this direction. If at once the body is in motion, it remains in motion, you are not applying a force. Okay, but in general phenomena we are not able to see this. How? When you roll the ball, so ball is not continuously rolling till you are not stop the ball. In some of the cases, ball stop itself. So how these things are happening? So again, Newton and the Galileo explained this. This is due to the frictional force. I have already told frictional force is opposed. Frictional force always opposes the motion of a body. So when you are applying a force on a body, okay, the body starts moving. When the body starts moving, it continues to move unless and until the force stop it. Okay, but in general phenomena we might have seen that the body will stop before you are applying a force to stop this. So this is due to the frictional force, due to air, or due to the rubbing that you are having. So I hope first statement is clear to you. I am repeating this. Everybody continues its state of rest or state of motion until and unless an external force is being applied on. It is written in notes also and in book also. You might have checked. You go and check this. So what second law will gives you? It gives you the definition of force. How? So if anybody would ask what first law will give you, so first law give us the definition of force. How? What in the first law we states that everybody continues its state of rest and state of motion until and unless an external agent will change its state, and an external agent will make this body to do so. So we know the external agent is force, so we can reverse the statement. So force is an external agent which has the property to change the state of rest or state of motion. We know at the first lecture, okay, the statement about the force. So from this law of motion, we can able to define the force. So what force is? So see, first you will go the statement and then we will reverse the statement. No, you will get the definition of force. How? So the statement says everybody continues its state of rest or state of motion until and unless external agent applies a force. This is the statement of first law, right? The statement or the definition of force says that force is an external agent which, okay, applies on a body and changes its state of rest or state of motion. I'm just reversing the definition. So this will gives you the definition of force. What second thing we know about this? It is called inertia. Okay. I'm not giving the name first. I'm just discussing this. What this first law says that everybody continues its state of rest. Supposedly this body is at rest. So it is at rest unless you are not applying a force. Okay. And if supposedly this body is in motion, so it is in motion unless and until you are applying a force to make this body to change the body to the rest position. So you see, there is a tendency in both the body to continue its state. This body is at rest, so this body wants to be in rest, wants to be at rest, sorry. And this body is in motion, so this body wants to be in motion. Are you getting my idea what I'm saying? This body, the first body, wants to be in a state of rest. But what you are doing, you are applying a force and you tell this body, okay, no, you have to change your state. Okay, you cannot be remain in this state. So with that application of force, the body starts moving. So in this case, as similarly, that the body is in motion, so the body does not want to be in rest. But when you are applying a force, opposing force to make the body stop, then the body only stops. The body does not want itself. So this kind of property is called inertia. What inertia is? So inertia is the tendency. What is inertia? So I am writing. Inertia is the tendency of a body. Tendency of a body to continue its state. State means both state will come, rest or motion. If anybody is at rest, it wants to be at rest. If anybody is in motion, it wants to be in motion. Okay, unless you are not applying a force. So this property will said to be inertia. So when the body wants to be in the state of rest, so it is called inertia of rest. When the body wants to be in the state of motion, it is called inertia of motion. Very simple. Inertia of rest and inertia of motion have been completed till now. So two types of inertia: inertia of rest, inertia of motion. Now next, see, why I have written mass? Because inertia is the tendency decided by mass. How? This is the first body, this is second body. If you are applying a same amount of force to both, supposedly 10 Newton force to both, so which one will move first? This one will move first and this one will move after this. Why? Because this is having huge mass. So if a body is having huge mass, it means it has more tendency to be at rest. And in the contrary to this, if this body is in motion, you have to apply more force to stop it. Okay, more force to stop it than to stop this body. Why? Because this is having more mass. So if any body is having more mass, it means it has the more tendency to continue its state. Okay, so this is called inertia. So we can say mass is the measure of inertia. If anybody would ask which is the measure of, and what is the, or you can say which is the measure of inertia, so we can say mass is the measure of inertia. What we can say? Mass is the measure of inertia. So inertia of rest, inertia of motion, you might have seen the different examples in our day-to-day life. What examples we can see? That See, so the examples of inertia that we might have seen is when you shrug the cloth like this, then cloth becomes okay, or you beat the carpet, then the dirt which is stick on the surface of the carpet removed and the carpet becomes clean. Why these things are happening? Because when you are beating the carpet, then carpet comes in motion, okay, but the dust particle which resides on the surface of the carpet wants to continue its state of rest. Then this body is, or you can say this particle is separated from this. In similar way, you might have or you can say you might have seen the example. I'm not having the particular arrangement over here. Supposedly, if you are having a glass tumbler and put a coin over here on a scale, when you just throw the scale like this, then this coin will fall on this tumbler. Why? Because this scale comes in motion while this coin wants to be in a state of rest. Okay, so this is the example of inertia of rest. Inertia of motion, it is very simple. When you boarded a bus starts moving. You just feel a shock or you lean backside. Why these things are happening? Because your lower part of the body will start or it comes to the state of motion, but upper part of a body which is associated with the seat, they wants to be in a state of rest. So that's why the upper part of a body wants to be continue its state of rest, and the lower part of a body is in motion. So that's why you feel a little shock or you lean a little backward when the car or bus starts. And when the car or running bus, train or any vehicle stops, you will feel forward. You lean forward, not feel, you lean forward. Why? Because your whole body is in the state of motion. When brake is being applied, so your lower part of the body which is associated with the floor of that bus, car or any vehicle, then it comes at the position of rest, but your upper part of the body wants to be in a state of motion. So that's why sometimes it moves or leans forward. So these are the examples of inertia of rest or inertia of motion. There are different examples given in your book. You just go through it. If you are having any problem, you can message me. So that's all. A part and B part we had completed, and the C, D, E three parts, 3 more parts are there. So we'll continue in each and separate lecture. So thank you very much for your watching. Keep watching your video and stay safe at your home. Thank you very much.